and then I'll pull up our questions, which I sent you earlier, some of those questions. But the first thing I was going to do is just kind of give you a chance to tell my students slash friends a little bit about who Tyler Wallace is. So 1 second, sorry, let me pull up the questions here. Okay. So I have two screens. One of them has the questions. So yeah, so who's Dr. Wallace? By the way, your LinkedIn has several degrees, including Spanish. So I'm excited to learn a little more about yeah, Tyler Wallace.
All right. Well, the boring part of who Tyler Wallace is I find education is a very expensive hobby that I love, so I keep going back to school. So I
Yeah.
have an associate's degree in computer science and mathematics with an emphasis in programming from community college. I have a bachelor's degree in Spanish, which included a study abroad in Spain and Costa Rica and Panama. I also
Wow.
have a bachelor's degree in mathematics, master's degrees in teaching secondary education, secondary mathematics, and also a master's degree in mathematics, pure mathematics.
Wow.
My thesis there was done in the mathematics of juggling patterns. It's all based in group theory, which was fascinating.
Wow.
And then I got my doctorate in educational leadership from Liberty University. And so that's why I'm officially Dr. Wallace now. More
Okay.
interesting note, though, I'm a math instructor. I have a passion for helping students understand mathematics and develop a love and appreciation for mathematics. That's one of the reasons why I'm out on social media. I'm
Yeah.
trying to help make math less scary, less intimidating, more relatable, more exciting. As Neil deGrasse Tyson said in an interview with CNN once, math needs better marketing, so I'm trying to be a part of that. So between TikTok and Instagram, I've got about 350,000 followers, and I'm just enjoying getting content up there and helping people connect with the mathematics.
Wow. Wow, that's excellent. And you're out in Big Bend, I believe, Washington or Oregon?
In Washington, yep, Central Washington State.
Okay. Okay. I've been to Seattle, and so that was a beautiful area. I haven't been to anywhere else, pretty much, just Seattle. But wow.
Seattle's the beautiful part. It's a great place to visit, but it
Yeah.
rains a lot there, so I don't know if I want
It,
to live there. It doesn't rain
yeah.
so much over here. We're in the high desert.
Oh, okay. And where are you from originally, if you don't mind me asking?
Originally, I'm from Eastern Oregon, grew up in the small town of Pendleton, which is
Okay.
famous either for its whiskey, its wool, or its roundup, its rodeo, depending on
Okay.
which crowd you roll with.
Okay. Yeah, I published a couple of books, not well, I published a math, how to do math well kind of book, but I haven't but one of my books was out of, I think it was close to Bend, Oregon, or Sisters, Oregon. I have
We have a bandana sisters, so yep.
Okay, no problem. Well, good, good. So one of the things I was gonna discuss is even just what that book you wrote, right? I've used many books in math, and my biggest concern was always this problem of examples. I don't like that books don't
Mm.
have a lot of examples. So could you just take us through a little bit of that part of your story? How did beginning and intermediate algebra happen?
Well, one thing that I was disgusted with quite early in my college teaching career was the cost of textbooks. Textbooks are so expensive. If you're a community college student, that textbook could represent up to 25% of your cost for going to college, not including your housing. And it just seemed ridiculous to me that something like math, that's just a simple problem, can be copyrighted and sold for profit by publishing agencies.
Yeah,
So I started making, with some other people in my department, we started making worksheets
yeah,
locally that we would just give to our students. And then those worksheets all came together to make a packet of stuff for our students. And then we kind of added some narrative. And then there was some money from the Bill and Melinda Gates Foundation to actually publish this books under an open license to try and make college textbooks and college education more affordable and accessible for people, which is right in line with our philosophy. So we filled out an application and got funded through the Bill and Melinda Gates Foundation to actually publish a book. And it came with a couple extra requirements that weren't in there yet. So we had to increase some parts of it, like the narrative, get a better answer key, a little more accurate there, a few more examples,
yeah,
and also put in what I called the worldview. It's kind of a multicultural element to make it kind of show how math is used all around the world. There was some great
yeah,
mathematics developed by the Chinese. There was some great mathematics developed by the Arabs, by the Greeks, by the Mayans, by the Aztecs, by the African community. And so there's different clauses depending on which section you're in that kind of relates math around the world to what's been discovered and how this has really been a global effort to get mathematics to where it is today.
Wow. That reminds me of this book I was going to talk to you about. I don't know if you've read it, Journey Through Genius by William
I
Dunham.
have not. I'm gonna write it down though.
William Dunham is a math professor, but he actually specializes also in math history. And so his book
Mm.
Journey Through Genius is what it inspired me to start doing math history studies. So I was a chemistry major. I went to school in Wisconsin. I grew up in Nigeria. So I grew up in Nigeria and came in 2007 to get my bachelor's in chemistry pre-med. So I was going to be a pediatrician to inspire kids. That was my goal. I wanted to inspire them.
Huh?
I was inspired by people like Ben Carson, the neurosurgeon, and I thought I want to be a
Oh
pediatrician too.
yes.
Yes, and so when I was in college, I worked in the math lab, and somebody had this book, and so I used to tutor kids, and I'll tell them math is beautiful. And then one day I read the chapter or the section about Newton, and I was like, wait a second, Isaac Newton was an ordinary person. He was just an
Yep.
ordinary guy, and I'm like, I could do math then if Newton could do it. Now we can't say the same about Gauss. Gauss was a little bit ahead.
He was a bit of a prodigy.
Yes,
Of course, I don't know how history is actually accurate and true. You know how the story embellishes over time, but it's
yes,
still a good story to tell students.
yes, yes. But even how Gauss writes versus Euler, because Dunham talks about it, Gauss is not as easy to follow. Euler is much more down to earth, like his Elements of Algebra book, which is my other favorite book. So your book and his are my favorite algebra books. But Euler is my favorite mathematician. So that's one question coming for you: is who's yours? And maybe if you don't,
Ah, so I'm gonna pick Euler because I just Euler's great because he's the goat of mathematics, right? Every
yes,
theorem he basically developed, and we can't call everything Euler theorem. We just call it by the second person who like worked on the concept because
yes,
everything started with Euler. He was so prolific in number theory and abstract algebra and geometry he was everywhere in
yes,
analysis, like whatever class you're taking, there's an Euler theorem in that class, or Euler's number,
yep,
or Euler's formula, or
yep.
he's everywhere. And I just love that he didn't specialize. And I also do not specialize. I like to consider myself kind of a generalist. And so it's neat to see all the places where it all comes together.
Yes, yes. Oh, well, in that context of what you shared, you remind me of Erdosh and the Erdosh numbers. So he's
Yes,
also, you want to be connected to Erdosh. And so we're gonna have to do maybe a fun video someday about famous mathematicians. I mean, I think that'll be fun. I'm new in the Instagram sort of numbers, by the way. I've been in the social media space, but I've more of just had my friends around, if that makes sense. I've been making content for my friends. But recently, I started making more general content, and that's when our channels met. I saw that you were on there again, and then here we are. But so no, I think that the mathematicians and getting people to just see their human side, I think that would be a fun. I don't know, maybe collabo someday, as the kids say on the block, a collabo on math history. But yeah,
I
so
love
this
it.
guy talk on Euler was very inspirational as well. And so I bring that up because when I read in your book about the worldview, some of the worldview sections you had about Euclid, or like the note on history, it was really just that's so cool. And so what I've been trying to do with my students is I'm actually encouraging them to read books like this, like just read like in the summer, because what it does is maybe it'll spark an interest. So this is one of the topics I was going to
Mhm.
bring up is if you've seen any sort of change in student attitudes based on integrating the history or applications of mathematics. Does that make sense?
I think the history of mathematics is kind of what brings the content alive. A lot of students really can get bored and bogged down in the algorithm of the mathematics. Why are we factoring? Why are we completing the square? Why are we finding these derivatives and these antiderivatives when I could just do it all on Symbol Lab? But when you
Yep.
understand the story behind how it was developed, all of a sudden it comes to life. I mean, if we're looking at infinite series and we're doing a proof by induction as to why 1 plus 2 plus 3 plus 4 is n times n plus 1 over 2. Is that right? I'm crossing my formulas.
Yes, and
Yeah, it'd be
it's
n
plus one
times.
over two.
Yeah, I did. Okay, just want to make sure I'm not going to misquote it here. But when you understand that there's a story about this, punk kid who stuck it to his teacher by adding the numbers from 1 to 100 in a matter of seconds, all of a sudden that comes to life and becomes exciting and interesting and fun, and
Yep.
it adds that element to it that makes it more interesting and relatable.
Yeah.
Because yes, we're doing math to model real world phenomenon, but there's a story behind how we got there, and those stories are what allows to make connections. We as humans want stories. We want to connect with other people on many different things. And the way we connect is through a story that we're like, oh, I totally get that story, or I
Yep.
understand where you're coming from, or that emotion speaks to me. And so we're trying to bring that math alive to our students.
That's excellent. No, thank you. That makes a lot of sense. And you are in a community college, so do you also have maybe some non-traditional students that really need to see, like, why am I learning this? Because again, they're coming back for a purpose to get things done and move on. Is that, would you say you see that from a 4-year college standpoint and a 2-year college standpoint? Is there any difference in using those applications and history, or should we just do it as much as we can wherever we can?
I think we should do it as much as we can wherever we can. It just so happens I'm at a community college, and so yes, we have a lot of non-traditional students and traditional students, and even high school students enrolling in college classes. So we get the whole gamut, which
Okay.
keeps the teaching exciting because I don't have just one type of student. I have all types of students,
Wow.
and it just is such a dynamic classroom because you've got people with no experience at life that are just excited to learn. And you also have people with tons of experience in life and are looking for a life change. Maybe they got laid off, or there was a recent relationship that ended that resulted in a need to get your own employment or something. So you've got all these different backgrounds and you put them together in a common space and they can inspire each other in some exciting ways. It's really neat that sometimes that 60-year-old student is going to connect with that 16-year-old student and motivate them to see a future that was possible just because they
Yep.
happen to be in the same classroom space together. So it's really neat to see all those combinations.
Yep.
And, good teaching is good teaching, whether you're teaching someone who's 16 or 6D.
You've got me thinking that community colleges are actually a very good option for people. I mean, I already had
Uh,
that view, but someone asked me that earlier today. They're coming from Europe and they wanted to know if they should consider community college first. And I think I'm liking what I'm hearing. And actually, it's getting me, it's like, wow, you get the young and those who are regular students in the like 1920. I mean, regular in terms of the general landscape in America. But then you also have the older students and you bring them in one place. I love it. I love it. Thanks for what you do there.
I also love that the community college really opens up education to anybody. We have no admission requirements, so anybody can be educated. And all the teachers are there because they want to teach. Their passion is teaching. And a lot of the universities, you get people whose passion is research, or you're not even taught by the researcher, you're taught by their assistant because they don't have time for you. But at a community college, it's really there to help students be successful, and they
Yep.
invest in their students and they believe in their students. And you're going to get a really unique experience at a community college, which is probably going to set you up for better long success because they actually care about teaching you.
Wow. 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 Thank you. This segment on community college, I'm going to revisit it and I'm going to recommend highly that students take time to go to a community college, especially if they don't know what they want to do. Like some kids just jump into the 4-year pool. For what reason? I don't know, because society says you should. So I
Yeah.
really love this. And I'm going to have to do a whole blog writing on just this topic and help people assess this as an option.
Yep.
One of the questions I have for you is your research in pure, well, any of your, I know you have multiple degrees, but any of those fields, but more so the math, as far as just, can you break it down to layman's terms? Like, what was that? Let me just grab my water. 1 second.
So you want to know
What
what I
was
did my
your,
research on for like my master's or?
yes, yeah, for your master's, like, can you break it down for ordinary people to understand? Like, I'm a
Sure.
chemist physicist, so I'm not a, I want to
Well,
be
I
a
wish I
mathematician.
wish I had a couple balls to illustrate juggling patterns, which I should have come prepared. But my master's thesis was all about the mathematics of juggling patterns, and the idea is each ball that's juggled is in the air for a certain number of beats. If you're in the classic cascade, that might be a beat of one before it hits the next hand, and every ball kind of goes the same height and the same distance. So that's called a
Wow.
1-1-1 pattern. And so it stays the same every beat. But if you do like a cascade where it's going in a circle, you've got a quick one, and then the other ball stays in the air a lot longer. And so that might be like a 1-4. So
Yeah.
4 beats before it comes down, based on the number of balls you have. And it
Yes.
turns out that when you get the pattern, if you average the numbers of the pattern, it tells you how many balls are necessary to do the juggling pattern. And then
Wow.
the inverse is true that if you take a certain number of balls, you should be able to generate all the juggling patterns that are possible using some things around groups and abstract algebra using what's called an isomorphic relation to Rn. Now I'm starting to get technical on you, but that's kind of the idea, though, is we can predict all the possible juggling patterns with a certain number of balls, and we can also determine, hey, is a juggling pattern possible? If I juggle with this pattern, Is it possible, or am I going to have two balls hit my head at the same time eventually? Or do I need an extra ball because there's like a missing beat that needs to be in there?
Wow.
And so you can do all the predictions there. So turns out that a lot of jugglers are mathematicians and a lot of mathematicians are jugglers, possibly because of that relationship. And it just makes sense to us naturally how we're working through these different juggling patterns.
Wow. Do you have the paper somewhere people can read or your dissertation?
I do have a paper. You can download it on my website, which is wallace.ccfaculty.org.
Okay.
And there's a lot of information on there, including a lot of my instructional videos and my resume. And it hasn't been updated in a while, so some of it's out of date. So don't
Okay.
judge me too much. But in the resume is where you can download my thesis and also my doctoral dissertation, which was in education. And that was more looking at what it takes for high school students to feel successful in college courses.
Really, if you don't mind, let's segue into that then. What was some of the
Okay.
takeaways to, because I teach high school, but I do have some people who are done with high school in a gap year program. Well, they're in a gap season. I love the idea of doing like a gap season where you can focus on reading good books and meeting people and job shadowing and then go on to college or wherever after. But go ahead, please.
So my doctoral dissertation took a look at dual enrollment programs where students are earning high school credit and college credit, and there's lots of different options to do that. And so I compared if they took a high school class that also awarded college credit, or if they took a college class that also awarded high school credit, or if they took an online class that could get credit for both, which format of classes was best to help that students what we call self-efficacy or self-belief that they can be successful in this domain or in this environment. And what I found was that what was best for students was kind of do a slow fade into that college experience. So if you start earning college credit while you're in the high school, then go to the college and still finish out your high school requirements, that transition really helps students feel like they can be successful, get that traction, and then feel successful once they're actually there on a college campus being a full college student. So rather than
Wow.
just throwing someone in, let's phase them in slowly and they're going to be more successful long term.
And what would that look like on a practical level? Would that be like a ninth or 10th grader taking college courses then?
Yeah, so there's a lot of programs around the state. They're called a lot of different things. But ninth, 10th, and 11th graders quite often in schools have the opportunity to take a class that the local community college or university will also grant them credit for that class. There's even an accrediting body that is over these programs called NASIP that kind of keeps an eye on them and makes sure the rigor level and the standard is still at the college requirement, even though it's being taught in those high school classes. It's a great
Yeah.
opportunity for those kids. I like it a lot better than the traditional AP classes because with an AP class, you work all year long and you take this one high stakes test, and
Yes.
everything is based on that test. And
Yep.
there's not even a guarantee that that test will transfer to the college you want to go
Wow.
transfer to. For example, my son took an AP test and earned a passing score on the AP test, but then he goes to a college where it needed a higher passing score to get the credit, so they don't accept it. And so it was just a waste of his time versus these classes that I'm talking about where they're actually earning college credit for their work in the class, all your daily work, all your chapter tests, all your in-class projects, all of that counts towards your grade. And then
Yep.
that grade becomes your grade on a college transcript for that class. And that
Yep.
class, because it's an accredited college, it should be able to transfer anywhere in the nation. So you
Yep.
get credit for your work all year long instead of one high stakes test. And it's guaranteed to transfer a lot smoother and it's just a better package all around, I think, for students.
Wow. No, that's excellent. So
And
actually,
again, we talked earlier with open source. I was going to say we talked earlier with open source and how I don't like publishers. AP is done by a for-profit agency that's trying to make money off of the teachers, the textbooks, and the students, and I don't like that philosophy.
yeah.
Education should be free to everybody, and this is a way to make it more affordable and more accessible to the world.
Yes, sir. Wow, I was gonna say I actually have a program out in Texas. So I'm based in Texas now. The university called Laterno University that has a dual enrollment program for high school students. They get these credits at a very low price, and they can take up to 60 credits. And so my goal is actually to be.
Yes.
I work in radiology. That's my day job. I'm a medical physicist, but I also teach math. That's my other job. And so my goal is to help these 9th, 10th, 11th, 12th graders have a pathway, especially those who want to be STEM majors. I want to give them the most efficient path to that. And I was going to talk to you about my reasoning, and I want to hear if you have pushback. I would love that just to get me to better assess my methods. So I was going to share some of my methods when you have a second.
Okay.
So Okay, let me talk about how I found your book, because this will answer this problem. So in 2011, 2012, I taught a high school algebra 2 and geometry class. And then in the summer of 2012, I taught algebra 1, algebra 2 and geometry. But what I realized was that a lot of overlap exists between those three courses. And even if you add pre-calc, they repeat graphing. So that summer, I came up with a plan. I said, what would it take to take all these courses? I'm just using these as examples. What if I took them and I found the intersection of sets and I removed every part that was duplicated and made it into one book? And that one book, you could go back as much as you want, but it has everything in it, right? And so the idea was, I wanted to know how many topics exactly are from basic counting all the way to calculus, right? The answer is 248. So it's 248 is the exact number of topics from basic 1+1 to the very end of trigonometry pre-calc. Now, why did I stop there? Because I believe Calc 1 is pretty well defined. Its differentiation limits, it's very well defined. Calc 2 is very well defined. But everything before that, there's just a lot going on with a lot of people from a lot of places. So if you move from Oregon to Washington, or from Washington to Minnesota, what school did you go to? What topics did you master? I don't know, right? And one of your videos recently, I saw that you had where you were talking to someone who was getting tutoring, or you're telling them about the importance of tutoring. And that is very important. But unfortunately, when I've tutored now for almost 20 years. When I'm talking to students, hey, what are you working on? I don't know how to do the whole thing. Okay, no, let's take a step back. Let's look at each strand, I call it. What is the thing you don't know about this, right? And actually, Anders Ericsson talked about it in his book. I don't know if you've seen this book, Peak. It's by Anders Ericsson, and it's called How All of Us Can Do Extraordinary Things. It's him and a science writer. He's a psychologist, and the science writer is, I think, has some math background. But they talk about deliberate practice. So Anders Ericsson is the one who did the 10,000-hour research. The whole idea people talk about to be an expert. So his field of work was studying experts and expertise. And I think that's pretty fascinating. That's what he focused on. And so what he said is, in order to be an expert, we need to train people on how to identify their weak spots and fix those weak spots, rather than this big statement of, I don't know, I'm confused about everything. And so my idea was, if I take these 248 topics and I can highlight any one of those gaps of those 248, then when you go into calculus, you should have all greens. I use green as my indicator for mastery. So you should have all greens, and you should tell your calculus teacher, here's my proof that I've mastered all the topics I need to be here. I just don't see that being the system around. I just feel like people are bouncing around trying, you know what I mean? In a field that is so precise, why are we just, like, you failed the chapter on polynomials. Why are you factoring, and doing rational expressions now? You shouldn't, right? You need to master this and then do this. So anyway, so that was my reasoning. And so when I started this project in 2012, I went to a math remediation workshop. And during this math remediation workshop, I learned about the college remediation problem in many colleges, where kids are coming in not prepared. Somewhere along that line, I came across your book, as well as David Lippman and a few other books that were written and put on My Open Math. And we've done a modified channel on My Open Math. I have on My Open Math sort of a course I built there. But what's interesting is your book laid out the examples, which is what I was longing for. And then it also gave out the practice problems, which was great. And then it gave them the solution. So basically, mastery now is more accessible to people. So your book fixes the algebra problem. And then we found a pre-algebra series that fixes the pre-algebra problem. So we have pre-algebra, we have yours. And then the challenge I always had was the college algebra. I didn't find as many books that had the examples and so on. I mean, there's some good ones, but your book kind of made me, like, it spoiled me. It made me want every book to be like that, because I wanted it very neat, if you know what I mean. Here's the neat examples. Here's the neat practice problems. And that's what I was trying to write. I literally was going to make the whole thing. So then when I emailed you about 10 years ago, I said, thank you, because I don't have to do this. You've done it. And so here's where it now comes to so I bring your book, I bring the pre-algebra, that brings them from counting all the way till the end of algebra 1 into algebra 2. Then I actually have found that college algebra and pre-calc are actually very similar. And if you're able to just do them well together once, literally you cover a lot of what you need. trigonometry can come later. So here's my course. My course is pre-algebra is level 1. Your book is level 2. And then I add a little bit to your book with conic sections and sequences and series because your book doesn't cover those. And that's fine because it's beginning and intermediate algebra. But by adding those to your book, that actually fulfills a high school requirement. So your book for algebra 2. So your book takes them through the high school algebra 2. Then I do a pre-calc geometry course. If you do those courses together, that takes you all the way to the doors of calculus. And if I start a student all the way in 5th grade, I'm seeing that some of my students are getting there in 8th or 9th grade. And I wanted to hear those pushback on Amos. Are you doing something wrong? Because if your students are in calculus 1 in 9th or 10th grade, you might be doing something wrong and you might be pushing them too far. What are your thoughts on my counting to calculus experiment?
Well, I think you're exactly right that the standards for different math classes are all over the map throughout K-12. And I think a lot of the reason for that is because we're preparing students for so many pathways at once. Really, calculus is only needed by those STEM students. And granted,
Yes.
all the STEM students are going to be on that calculus pathway, and there's a good number of them. But
Yep.
some people are more of a statistics pathway, or some people are not even going to be going into a career that's going to use much mathematics. And
Yep.
so we're putting them all in these same middle school and high school math classes. And so these classes are serving so many different masters. They're being pulled lots of different ways. So we need
Right.
to do a statistics unit. We need to do a probability unit. But we also need a heavy algebra unit. And we also need and if you didn't do well in this algebra unit, that's okay if you're going to be doing well in the statistics unit because you're probably going to be going off the statistics pathway. And so there's all these different people, all these cooks in the kitchen, and we end up
Yep.
with this hodgepodge thing we call algebra 1 or algebra 2 or pre-calc. It's not well defined at all. And like you said, topics from state to state, even from school to school, are so different that we cannot, what's algebra 1 to me may not be algebra 1 to somebody else. And so it's very difficult to get that standardized curriculum just because we're serving so many masters. And so
Yep.
when you're trying to get a pathway at such a young age to calculus, the challenge you run into is at that young age, a lot of them don't know if they're going the STEM direction or not. So
Great.
do they want to do the work to get on the bandwagon to be calculus ready at this early level? And that's challenging because I really don't know if we want to pigeonhole students so early into a
Yep.
certain pathway. So I'm not saying they're capable or not capable. I'm just saying, is that where their passion's going to be? Because if you're going to be a social worker, that's important work that you're doing. And you
Yep.
probably only need a basic understanding of statistics to do that in
Yep.
terms of mathematics. So we don't need you to go through the rigorous pathway because that's going to become demotivating to you and possibly derail your dream. And we don't want you to
Yep.
not become a social worker because you couldn't simplify a rational expression. That doesn't make sense. But if you're going to become an engineer, you better be able to simplify and factor and reduce and evaluate and work with functions and combine functions and all of that.
Yep.
So that's one reason why I think the curriculum is so spread out.
Right.
Another reason I think we come back to topics all the time, because you do solving equations in pre-algebra, then we solve equations in algebra 1, then we solve equations in algebra 2, and then even in pre-calculus, we're solving equations, but maybe just with the generic form of ax plus by equals c instead of with numbers, but you're still
Yep.
doing the same thing. Part of the reason we come back so often, I think, has to do with what researchers call the curve of forgetting. If we
Okay.
don't come back and review some topics, we're going to forget those topics. And so I
Yep.
think the curriculum intentionally loops back around and says, remember
I
this
see.
topic? Okay, we're going to go a little deeper. Remember this topic? We're going to go a little deeper. Okay,
Yep.
remember this topic? Okay, we're going to go a little deeper. The problem with that is it slows down the curriculum. We can't move as fast because
Great.
you're always going back and reviewing.
Yep.
So that's one of the reasons why I think you see what you're saying is we're losing a lot of time, we're reteaching, we're going over things over and over again. And also, if a student failed factoring last year, we don't want to say you can't be an engineer or you can't be a
Yep.
doctor. We want to say, okay, let's give you another opportunity to master factoring so we can get you into those advanced classes. And
Great.
so I think that's part of the reason why it cycles around so much. Now, if you do have a group of students that are focused and they know that's what they want to do, they're going down that calculus pathway, the STEM pathway, whether it's science, technology, engineering, or they want to be a mathematician even. Um, but they definitely, I think, are capable of going through all those steps and being
Yep.
successful at it and taking calculus at a young age. The youngest calculus student I've ever had was 15 years old, so that'd be probably 10th grade.
Okay.
But there's no reason why a 14-year-old in their freshman year of high school wouldn't be able to do those topics. They
Yep.
just need to make sure they have that strong foundation. They need to know how to factor. They need to know what a function is and how to manipulate a function. They need to be able to recognize patterns and manipulate patterns. When you're solving 5x plus 2 equals 3, they shouldn't see 5, 2, and 3. They should see y equals mx plus b and understand how those pieces work together and an abstract view of how it's working together. And if
Yeah.
they can do all of those things, they've got the strong algebra skills, probably strong trig skills as well, because there's a lot of trig in calculus as well, especially in calculus 2 with the integration.
Yeah.
Um, I definitely think they can be successful. It's just the challenge of we want to make sure they don't forget the topics. So we have to go back and review.
Yep.
And are we pigeonholing them in a pathway before they're ready to be pigeonholed into that pathway?
Yeah. So I love what you're sharing there. And I'm like, man, I don't know how long you have. I was gonna keep you too long today, but we have to do a part two if you don't mind, because I have
Okay.
questions that are in my head that I think I'm gonna follow up on a question based on that. But I love books. That's part of my weaknesses. I just like books too much. And there's one of them
Good
I
weakness to
actually,
have.
oh, do you like books, you said?
Yes, it's a good weakness to have.
Yes. And
Never
so,
stop learning. That's what I say.
yep, yep. So Barnes and Noble is dangerous. If I go in there, it's
Oh,
a
spend so many hours and dollars in that store.
yeah, but I was gonna say it's I think that even I can send you my follow-up, but some of my questions are more in the specifics of how to be good at math, if that makes sense. I think that's almost a cool sit down interview discussion that I can put together for your people and mine to go back and I'll send you this video so you can share it too. But there's a guy named Jake Ryland that wrote a book called Becoming an Engineer, and he has a YouTube channel. Jake Ryland, I heard about him through his YouTube, and what he said was 50% of kids drop out of engineering school, about 50%. And so it got me thinking, well, and he talked about the data and all of that. And he said that part of it was because people were not prepared well enough. And so that's what's happening. And you are right. You hit the nail on the head when you said we have too many directions. So let me just share two things quickly, and I'll come back to calculus. One of them is in Nigeria, we actually get put in tracks in 10th grade. Now, I know that some people might not like that, but that's what Germany, India, I think some of these countries do. You have to choose a track. That's worth a debate someday, people that might have different views on that. But what I can say is that I had a track. I'm not a doctor today, even though I was on the doctor track, but that training was still helpful. And, now I work in medical physics. It worked out. But I feel like there might be a downside to having no track necessary, and therefore people are just running all over the place, undeclared and not sure what to do. So here's my take on what you said about calculus, though. In Nigeria, everybody actually has to do calculus, which is kind of sad. Everybody, yep, the whole country. Because
Wow.
in 12th grade, there's a standard math class. And maybe next time, if you want, I could tell you how we do it, because Nigeria is one of the stronger countries in math. And one of the things they do is everybody does calculus, and our math is integrated every year. So you don't do algebra alone. You always are doing algebra, geometry, trig, if that makes sense. You're always doing a little bit of everything every year. But then in 10th, 11th, and 12th grade, those in the track of engineering have to do 3 math classes simultaneously. So they have to do their regular math that everybody's doing with one teacher. Then they have to do advanced math with another teacher, they call it pure further mathematics, and then applied further mathematics. So I had to do 9 math courses in 10th, 11th, and 12th grade. So when I graduated 12th grade, I pretty much had Calc 1 and 2 and all of that I had to learn. Now, I must confess, at the time, I wasn't a fan of Calc 2. I wasn't a fan. I was like, what is this? Why am I doing this? This is painful, And so now when I came to college, I took it here and it made more sense. It was still painful. I think calculus 2 is the most difficult class for many people. But I bring that up to say when the bar is higher, I feel like it does something to the society, right? They pull us all up. Now let me say, I agree with you with the social worker, but here's my take on calculus. And this is fun, just for fun. I think everybody should do calculus because it's beautiful. That's the reason.
Ah, I definitely agree. It is a beautiful thing. Yep. I think it's kind of like the same thing as to why do some people go camping? Why do some people climb a mountain? Why do some people Because it's beautiful and they're passionate about it. I've run a marathon. It's an amazing experience to run a marathon. But when I tell people that, they give me that reaction that you just did, that face of, I would never do that. And I guess the problem is we all define beauty so differently.
Yep.
So just because I love running a marathon, does that mean everyone should run a marathon to experience that beauty? My wife ran a half marathon and she experienced no beauty on any mile of that course and said never again. So and I think that's one of the beautiful things about us as a society, though, is we are all have these different passions and interests and things that we call beautiful. And
Yep.
that's where we end up with beautiful art, beautiful support systems for
Yep.
underprivileged youth, beautiful stories of success and giving and generosity, and beautiful mathematics is it's just all beautiful to different people. And so we end
Yep.
up with all these beautiful areas of life that we can share with each other.
Yes. Have you read the book Math for Human Flourishing by Francis Sue?
I haven't. You're giving me quite a book list here, though. Math for Human Flourishing.
Yes, so he wrote a book and he talked about a prisoner that came to love math and started writing letters to a mathematician or something. And so he talked about how math was used to, just for human flourishing. And I think my take on it, though, Dr. Wallace. So I'm not an aggressive calc pusher. I'm saying it's beautiful. I know it
Yes.
might be difficult for you, so I'm gonna make the process very less painful than could be. You know what I mean? I'm gonna make it a gentle process of understanding. So by that I mean I'm going to make sure you understand how to factor polynomials, rational expressions, finish Tyler Wallace's book, and then let me check your gaps, make sure you're solid, and then let's walk gently into limits. You know what I mean? It's almost
Mhm.
like maybe the year-long calculus journey is for those who just want to learn it to say I've learned it. And then those who want to go into engineering, we make them go through it by semesters. Do you know what I mean? Like we get you in
Oh, okay.
semester 2 because and this is something again there's so much we could cover, but I'm going to write my questions and your insight is already helping me revise how I teach. But what I was going to say is one of my students said to me, I wanted to be an astrophysicist when I met you, but I think I've given up on that because of Calc 2. And I told
Uh,
him, wait a second, Calc 2 is hard for many people. And then he said that he actually didn't have a teacher. He had to do an independent study. And I said, what are you
oh,
talking about? That's a
that's the
painful
worst way to do it.
thing. Yes. And so what I was trying to tell him is don't allow Calc 2 to hinder your progress. But then I was talking to him, and I'd love to hear your thoughts on this before I show you my last major question. But what I told him is maybe we need to do Calc 2 over 1 year. Maybe we really do. Maybe it's just too rigorous for one semester for people. What is your take on that? How can we reduce the pain of Calc 2?
That's a great question. So I don't think there's any reason it has to be on any time frame. I often tell my students anybody can learn anything given the right amount of time and the right environment. And it's not a race. And sometimes we take longer to learn things, and sometimes we don't take longer to learn things. But anybody can learn anything, barring a disability, of course. But
Correct.
generally speaking, anyone can learn anything given the right amount of time and the right environment. And so my job as a teacher is to try and create that environment. I can't control the timeline because things outside of my control say I've got an 11-week quarter and I've got to finish in the 11-week quarter. So I'm stuck with the timeline. But I'll work on the environment, and maybe the student needs to retake the class, do it a second time. Maybe that's what they need to be successful, and that's okay because it's going back to my marathon analogy.
Yep.
It's not about nobody cares who wins the marathon.
Yep.
All that matters is you finished the marathon. It doesn't
Yep.
matter if it takes you 2 hours or 5 hours. Although if you did in 2 hours, there's a little bit of fame and fortune that would come with that. But it doesn't matter who's first, second, third, 20th, 5,000th. Everybody who crosses the finish line gets that same medal. And it's the same thing with education and learning is it's about finishing and getting to a goal, not on any timeline. So if it would be beneficial to stretch it out, why not? I don't think there's any reason why we can't, other than it does become difficult with the way colleges are set up and credits and transfer and all of that. And so that's a big system that we're stuck with. But in terms of learning it independently or as a supplement, or even in high school, is a little bit more flexible, we
Yeah.
can definitely play with some of those options.
Wow. And if you don't mind, the last thing on Calc 2, can you pinpoint part of what is unique about Calc 2 that just derails so many people in terms of, I mean, even me, when I was taking it, I had a good friend from Cameroon which is another country that I've just noticed a pattern of certain countries like Singapore, Cameroon, where these students have this solid math background when they show up to America. But what is the thing about Calc 2 that you feel like maybe it's a harder process or takes longer to work problems out? What's up with Calc 2?
I think Calc 2, which is usually your integral calculus, and usually it's the integral calculus beyond just U substitution. What it will do is it will expose any gaps you have that you've been able to compensate for or cover up in the past. It's
Wow.
going to expose you because one problem, take partial fractions. With partial fractions, you'll need to factor. You need to be able to simplify a rational expression. You need to be able to solve a system of equations. And sometimes you end up with an irreducible quadratic that you need to break down into its elements so that you can identify the tangent inverse element and the U substitution element. So you need to be able to see the structure that lives underneath it, that function notation that we talked about. And all of that's in one problem. And so if you're weak in any of those, it will expose you and you won't be able to solve the main integral of the partial fraction problem. I tell students all the time, calculus is actually very easy. It's two questions. How fast is it changing and how much has it changed? That's derivatives and integration.
Yep.
The algebra and the trig that's underneath all of that, though, is very rigorous. And if there's a spot where you're weak, you will be exposed by calculus. And they're exposing your algebra weaknesses. And there's no way around it. You have to learn your algebra. I'll have students tell me all the time, I never learned trig till I took calculus, and it forced me to learn trig. Well, good. Now you know trig.
Yeah.
And
So
that's the thing. What's challenging about Calc 2, though, is it brings together so many algebra and trig and geometry concepts. And then we also throw in a little bit of physics and chemistry and maybe some business in there with the applications and say, do it all at once.
yes.
And it's the first time students have had to do it all at once.
Wow. So one of the things as you're sharing, I'm saying to myself, I needed a note and I have a notebook, but I'm like, I could just take your class and I'm gonna go back and I have your my open math. So I have resources, but I'm just gonna have more of my students tap into some of what you have with your resources. I noticed that you're also connected to a Instagram channel that has like calculus notes. I thought that was cool that somebody has their notes. I mean, note taking is something students need to learn, and in America, it's not mandatory. But I think that's our problem: is that people are not taking notes in middle school, high school, so they get stuck. You're not gonna
They
do
don't
an
know how to,
integral
but
in
they
your
get to college. Yep.
yeah. You're not gonna do Calc 2 in your head. I mean,
No.
it's just if you do, there's something wrong with you in a good way. But yeah,
There was once I was hearing a story about my predecessor who taught calculus before me at my college, and he was telling me one time he had a student that was blind in his calculus class.
wow,
And he said this, so the student had a accommodation, a person would help them take their test. And it was great because the accommodation person had no idea anything about math. And so it was obvious that this person could not help them cheat. And they would tell the student the question, you're integrating, what is it, sine cubed times cosine cubed dx. And the student would just close his eyes and sit there. You'd almost think he fell asleep, right? And all of a sudden, he'd open his eyes and be like, "It's negative 1/6 sine to the eighth minus." And he would just say the answer. So whatever was happening in his head, it was happening in there. It took
wow,
a minute, but he had like this mental piece of paper that he was working on
wow.
because when you can't see, you figure out how to do it mentally, and so do it. But like you said, it is not common to be able to do that Calc 2 stuff in your head.
Wow. So just so you know, Euler went blind, right? He went blind,
Yeah,
and he would have to do that too. And Journey Through Genius talks about him, but there's actually a book by William Dunham. Dunham has written a lot on math history, and one of them is called Euler, the Master of Us All. That's the subtitle.
I love it.
Euler. So then the last questions are like rapid fire. One of them is calculus or statistics. If we had to make it mandatory for all 12th graders, which one, either or?
I'm going to actually say statistics, which is probably a surprise. We need a more educated statistical community out there. There's so many statistics that are thrown around and claims that are made that they need to understand what's going on to be an educated consumer, voter, buyer, member of society. I do think calculus is important,
Yep.
but everybody is going to interact with statistics at some level. So sorry to surprise you, but I'm going to say statistics.
Okay.
Next one.
Can we have a compromise and just say both?
Okay, I didn't know that was an option. We did both.
Deal. Both. Okay, good. Because and there's a professor at MIT. He just retired. Gilbrand. I don't remember if you know him. He was very old. Like he taught linear algebra for many years. He actually would say linear algebra. So he says you should do linear algebra because you could do it before Calc 1. You know, it's like it doesn't
That's
have
true.
to be. So then it's like linear algebra, statistics, and calc. So Amos is gonna say 3 of them. So okay, next question. There's a book here called Math Fix by Wolfram. There's Wolfram Alpha. He says that we should change how we teach. And I'm going to try and dig into his book more. But part of what I understand him saying is that we don't need to focus on a lot of the calculations-based issues because we have machines that can do it better than us. What is your take in times tables and math facts being memorized and held onto in the K-12 space as opposed to depending on tools like computers and so on? Do you see what I'm saying? Where do we stand on that?
I think there's still a need to be able to look at a problem and intuitively say the answer should be something like this because I understand what's going on. That way, if I enter it into the algebra system, the computer incorrectly, and it spits me out a nonsense answer, I know it's nonsense. So if I'm
Yes.
talking about investing $100 a month at 5% for 2 years, I'm not going to have $40,000. Something's wrong, or I'm
Yeah.
not going to have a negative amount of money. So you should be able to look at a function or an expression or an equation and know kind of what it's going to be. Also, a lot of concepts build on that basic math facts. So you need to know your multiplication tables because without knowing those, you can't factor. And if you can't factor, you can't do partial fractions. And if you can't do partial fractions, you can't do Laplace transforms. And if you can't do Laplace transforms, you can't. And so it just builds on itself so quickly
Yep.
that you need to know those foundational concepts. So I do strongly believe you still need to know your basic calculations. You need to be able to know how to derive an answer. You should be able to know approximately what the answer should be, or at least what it should look like. So if you
Yep.
get a bogus answer from the system, you know it's wrong. Because what the computer can't do is say, does this make sense? The computer just
Great.
spits out an answer based on the input.
Wow. So in his, he does talk about hand calculating and that not being the essence of maths, and he has some great topics there. But I feel like my solution, and I'll read it and I'll put it for one of our future talks. But what I'm trying to get at is, I get what he's saying with the fact of the resources out there, but I feel like we can do both. I think we can still get our fundamentals, and
Yes,
we should look at how to use math for modeling. He's saying we need to do more with modeling things. I think a lot of
I
math
do agree with
students
that.
don't, they can't do much with the concept outside the book. They just do it in the book. But if you told them, hey, can you build me a model or write a function? They might be like, nope, I'm just trying to pass my class. I'm not trying
Yep.
to do that.
And while I believe things like your multiplication facts are important to learn, you only need to know the multiplication facts through 10 because the technology is going to take care of that afterwards. We shouldn't be spending time doing 4-digit times 5-digit numbers. That's a waste of everybody's time. Nobody does that by hand. We can actually look at modeling what is multiplication used for to model real world situations. We can look at why do we multiply in this real world situation and add in this real world situation. We can look at why units are so important that we can only add like things. We can
Yep.
multiply unlike things and what that means and what that looks like. So there's definitely a balance between the two. In education, we try and swing the pendulum and be like, it's all procedural fluency. No, it's all real world application. No, it's all, well, the answer is neither. It's actually the reason we swing back and forth is we keep missing the right answer, which is in the middle. We need a mixture of procedural fluency, real world application, and conceptual understanding with equal intensity.
Wow. Wow. I love it. I mean, I think a math class, like some math teachers feel guilty when they talk about the applications because they're like, we got to stay on track. We got to test at the end of the year instead of being able to just
Yep.
pause and let's talk about how prime numbers are used in network and I mean in encryption or credit card encryption
Oh,
or whatever. Like, wouldn't that be cool to just have a day on that? Some teachers feel guilty, but I wish that changes someday. So real world applications, then, what are your favorite real world applications of math? If you had one or two to just get somebody excited to see, wow, math is involved, like something that is not as common to the lay person on the uses of math in everyday life.
so I have two answers. The first answer is going to be my favorite application is showing how antiderivatives can be used to model an annuity and show a student how they can be a millionaire. They eat up this lesson because what I do is I pick on the youngest student in my class who's employed And I say, let's say you're a total loser and you're working part-time at minimum wage from the time you're 16 to 65. You never get a raise, you never work more hours. You're just going to put 15% of your income away for this 40 years of working. And the students are like, wow, you're putting away like 14 bucks a month or what? It's a small amount. But if you do that for 4 years, compound interest is an amazing thing. And they
Wow.
always have like $3 or $4 million at retirement. And
Wow.
they're like, and then the students get excited, like, wait a minute. Calculus stuff actually can say that it's not hard for me to be a millionaire. All I have to do is invest from my early working years till my later working years in compound interest. Yeah, let's talk about compound interest. Supposedly, Newton said the strongest force in the world is compound interest. I don't know if that's actually true, but he supposedly said that. And
Yeah.
so I like to repeat that because it sounds good. I'm not a history sensationalized, but it really gets us excited about that topic. And I even tease it like the week coming up. Next week, I'm going to show how calculus makes you a millionaire. And there's nobody absent on that day. They are all there. They are ready to go and find out how it works. And they all have all these great follow-up questions. It's a great application. So I really enjoy the finance of money because everybody's got this American dream to be a millionaire, own your own home, and all of that.
Yep.
The other application though, that I really enjoy is, and it comes up in so many places and it's not very complex, is the mathematics behind determining who wins an election that has more than two players in it. Because if there's more than two players, we can rank order our preferences. And so now we can talk about politics, and nobody likes Biden and nobody likes Trump, but there are only options. No, there's these third party options. Well, if you vote third party, you're throwing away your vote. And I'm like, well, what if? And then I say, what if it was ranked ordered voting? So if you believe that party X is the spawn of Satan, you could say your preference is one, party Y that you don't like is number two, and then spawn of Satan is number three. And then you've got this ranked order voting. So how do you determine who wins? There's lots of ways. We can do it like they do NFL MVP, where everybody first place gets 3 points, second place gets 2 points, third place gets 1 point. Who's got the most points? Or we could do it like Alaska just did their primary elections, where nobody has 50%. So whoever got the fewest first place votes gets thrown out, and all of those votes go to their second place person. And now we recount the vote and we see who won. But where the students get really excited is we're always trying to make the election fair because students really have the social justice drive underneath them. They want everything to be fair in the world. And with each voting method, there is a reason why it's not fair.
Yep.
And so we talk about why this is not fair because of this situation. So we need another voting method. So now they're like, okay, this next one's got to be the fair one. So we have this other one and it fixes that problem, but it creates another problem. And so it's not fair either. So we look for another method and another method. And we just come up with there's a bunch of methods. None of them are fair. We just have to kind of decide which one we like better for the context that we're in.
Yeah, I wish our electoral system someday will adjust, but because of that ranking order, I like it. In Nigeria, it's like that. Now, I understand the electoral college votes. I'm new to America. I'm a citizen, but I just think that there's some interesting worlds out there with politics, and I think it's interesting you brought that up. That there are other methods that could be considered. Yeah. Anyways, I'm more of a academic person, but I do think, of course, that people can have cordial conversations. Our culture is so supercharged. It's like just have cordial conversations, and that's key. No, that's really cool. Thank you for those two applications. I'm gonna keep that to heart. Oh, I forgot to tell you that when you mentioned Calculus 2 has all these things thrown into them, I actually think that teaching chemistry, physics, and math together has a benefit because you get to see why Newton did what he did. Imagine taking the reason he did it away from the point,
That's what we do. We're like, hey, let's just find the area under the curve. Why? Because.
Just because. And then the kids like, hey, factor this polynomial for no applicable reason because you just have to do it. Now, I tell my kids that it's a character lesson. I tell them, let's just build your character. But you have to be upfront with them and be honest. If they ask, when am I ever gonna use this? I tell them sometimes you might not use it, but look at what happened with Fermat's last theorem and some of these things that nobody used back then, but today they have some use. Or even like a Fourier transform has more uses now, maybe than he thought about. So I think our students, a lot of them are coming with the question, why? I have all these distractions I can go hang out with. You're telling me to come here. Why am I here? And so my mind is always thinking about, make this applicable, make this relatable, make this to matter to them. And if you can't make it matter, tell them to build character. Just build
There you
character.
go.
Yes. Okay. So lastly, mathematics for machine learning is I don't know. Are you guys doing anything with this type of like math for machine learning or space mathematics? Like, where does that fit in with K-12/college courses? Or should we just leave this to the computer scientists? Just push it off to the side. Or can we get the public?
I don't think we should ever look at the computer scientists as separate from mathematicians. I think computer scientists are mathematicians, and so
Okay.
it's definitely an important element of that. Now, I don't know much about machine learning specifically, but I do know that our computer scientists are mathematicians. Our scientists are mathematicians. Going back to that comment that you made earlier, why do we study math in isolation? We need to be studied in the context of physics, in the context of astronomy, in the context of chemistry, in the context of computer science, and then it comes to life. Because when I'm taking linear algebra, I have no idea why I have to do a projection from a 3D space onto a 2D space. But if I tell you, if you want to program a video game that has a three-dimensional environment that's being
Yep.
projected on your two-dimensional screen, so you need to know how big to make that thing so it feels three-dimensional as it moves forward and backwards. All of a sudden now it has meaning because you're
Yes.
going to make a vector from the thing to the screen, and based on the size of the magnitude of the vector and the direction of the vector, you can figure out how big to make it. And it all has to do with graphical design.
Wow.
Why do we need Newton's method? Well, we need Newton's method to display characters on a computer screen because characters on a computer screen really are just straight lines, tangent lines to a polynomial curve with an estimated solution used by methods like Newton's method. And so if we understand how it all comes together, all of a sudden it comes to life and there's a reason I'm learning these things, not just because some old dude 50 years ago said it had to be part of the calculus book.
I think, would you ever consider doing sort of a addendum to your book, or like even a video series, or just a discussion going over the 10 chapters you have there? Because you have them well laid out, those 10, right? And I don't know, is it the same edition we're talking, or did you do a newer edition? This is from
I
2014.
don't think I've done a new edition in about 10 years. So if it's
Okay.
probably the same one.
Okay, because I was thinking, how cool would it be if like the chapter on equations has like this extra section on, here's a video. It's almost like those things where people have a course that has a video that goes with the book, and the video part just, goes over applications. So then I'm thinking I'm just gonna play those videos or have them integrated into, hey, when you do chapter 1, you have to watch that video. And guess what? Maybe we're going to assess your knowledge of the video. So imagine if our tests were not just on the understanding of the concept, but they also tested your understanding of how it came to be, why it matters, etc. Does that make sense? Like,
Mhm.
wouldn't that be a cool? Does anybody do that?
I don't know that I've seen anything like that, but I definitely think it would meet a need that's out there. And one of the great things about open educational resources is I might not have time to put together a series, but if someone to put that series together, they could couple it with my textbook and they could run with it. And there's no fees or royalties or anything to worry about because it's about getting education out there to the people and making educational affordable and accessible to everyone.
Yeah.
So make the package bigger. And if someone wants to rise to that challenge, I think it could make the package, the product, the lesson, the learning deeper, stronger, and better for our students.
Wow. Wow. No, thank you. That makes a lot of sense. This is my last book of the day, Understanding Mathematics from Counting to Calculus. So when I came up with the idea of Counting to Calculus, I wanted to make sure nobody else had a book on the market with that title, because my book was going to be one book and just, here you go. Kind of like Ramanujan had one book that he studied, and then Ramanujan, of course, went to Cambridge, and the rest is history. But there were actually 4 to 5 books with this,
Oh
like,
no!
yeah, well, it had Counting to Calculus in the name. And so for me, I see that there's a niche of people that want a condensed math version that just takes them straight to the point of where they need to go. So with AI and all this talk, if I don't know like algebra, but I feel like I need to change jobs to help my family, I just need to get a book like this to learn all the math. And in this one, they actually do cover linear algebra. That's a big part of it. And so it's cool for students to see the big talk of AI connects to their math in the classroom. So, anyways, I saw this here, and I'm your resources, like your book and the one I'm using from Redwoods, College of the Redwoods. That's my pre-algebra book. You guys give us
Yeah, they have a good one.
a better base to build. But now I want to learn how to code Python and data, Oracle. Even though my wife and I have 7 kids, so coding is going to be a huge task. But my goal with that is
Got no
what.
free time, buddy.
And my firstborn is actually using your book. He's in chapter 5, so I'm proud of him.
Oh, excellent.
He's 11 years old and he's doing your book. So, but I was gonna say it's interesting because what I want to do is I want to gamify my counter to calculus. I want to take those 248 topics. You click the app, and it's this cheap app that just has all the math videos for every topic. It has practice problems. It has inspirational videos of math history and math application. So basically, when people scroll like social media, they can also scroll my app and watch, oh, Newton did this. Oh, Euler did this. Lagrange. Even though I don't know Lagrange as well, but his name just sounds so cool. Lagrange. Anyways. But yeah, so anyway, so that's kind of my vision is, so if you have any suggestions and so on, that'll be great. But I want to then give it to colleges to use for remediation to accelerate learning, so kids can take the summer before the first semester and learn at least get them better established so they're not as anxious about math, which is my last comment. Math anxiety. Do you have a solution for me to give my students?
I don't know that there is a solution, because if I had the solution, I would publish it and retire. But there are many things that we can do to help with the math anxiety. For one, and this goes back to my research on self-efficacy that I did, is we need positive experiences with math to realize that it's not a scary and bad thing. Albert Bandura, who is a psychologist that worked around self-efficacy, looked at people that have phobia of snakes. And he found out the reason people had an unreasonable phobia of snakes was because they had a bad experience with the snake at some point in their lives. And
Yep.
so he started creating good experiences with snakes. So if it started with like a snake in the room while they were eating cake. And then the snake might be closer while they received a massage or something, and then maybe they touched the snake and then they got a dessert of some sort. But there's some type of positive reward that's connected with every interaction with the snake. And then over time, because of all these positive interactions with snakes, the people were soon holding snakes. They were playing with the snakes. Obviously, these are, safe snakes, not like
Yes.
scary, dangerous snakes. But um, and so the idea, though, is by creating those positive experiences, they got over that phobia and that anxiety. And that's what we need to do with mathematics, is we need to find ways to give students positive experiences and successful experiences with mathematics. So don't start them out with something that's going to overwhelm them and scare them away. There's a lot of mathematicians, what I'll call the old guard of math education. Math is like, we are the gatekeepers to STEM, and you have to get through us to access STEM. And that needs to die. We need to look at how we can open the gates and include as many students as possible. And so, what can we do about that? We need to give students those positive interactions with mathematics. We need low stakes exams that are more formative assessments instead of summative assessments to help them grow their learning. We need to have more collaborative mathematical experiences, because very little mathematics was actually discovered in a vacuum. Pythagoras gets credit for that theorem, but really he had a whole cult of people that included women dedicated to studying mathematics and numbers and ratios. And through that collaborative experience, all geometry came out of it. And that's same situation all the way through academia. Very few math concepts were developed in solitude. Why are we making students sit in rows, work on their own, listen to the teacher quietly, and then regurgitate on a test? That's not going to create a positive
Right.
experience. We need to find ways to, like you said, gamify it, make it exciting. That's one thing that I like about my TikToks and Instagrams that I make. As students are scrolling, they're going to see math in an interesting, exciting, funny, memorable way, not a dull, dreary, boring way.
Yeah.
And by changing those interactions with math, we're going to start to change that anxiety that students are experiencing with math and hopefully give them a better experience. There's other ways too that we can do. You can do vicarious experiences and say, hey, someone like you was successful, so you can be successful too. We can
Yep.
give that verbal persuasion where we can say, hey, I know you can do it. I believe in you. I've seen you be successful. You can continue being successful. We've got the physiological state that affects everything too. If you're sick or you just received bad news or there's a major event in your life, you're not going to be able to focus and be successful. But the big thing that influences that self-efficacy, that belief that I can be successful in math, is those mastery experiences, those positive experiences that a person has. And so we need to find ways to emphasize those, celebrate those, and make those more accessible to the population. That's going to be what addresses the math anxiety issue.
Wow. Wow. Do you have a podcast?
I don't. Do I need to start?
Yeah, well, I mean, yeah, even if you gave me 1 hour a month, I could definitely learn a lot. And so, but if you want, I do a podcast of my own called STEM Excellence, but I just love talking about science and math. I'm interviewing one person from every branch of engineering, and then
Well,
so that's my
excellent.
series for the summer. But then you're kicking us off in that series of the math, right? We need math to do
Great.
engineering. But no, if you need someone to just, I love asking like a journalist. Like I sit down and I ask questions. I love asking those questions that I believe could benefit some of the people that I know I'm trying to help, if that makes sense. So I love being like their sort of their channel to get the questions that will then help them, because I call some of my math work inspirational mathematics. I'm using math to inspire you as much as you're right. Some people are like, oh, I hate math because of an experience. Well, I watched that happen when we did determinants of matrices in a 2x2 matrix. A lot of kids who maybe had a bad experience, when they saw they could find the determinant, they actually asked me for more problems because they had seen the pattern. They were like, I see it. Give me more, because now I see. But then I told them, math is almost everything we teach you at this level is gettable. I call it gettable. You can get
Mhm.
it. I can't guarantee when you get to PhD school or try to solve Fermat's last theorem, you might not get it, but you can get it at this level. So I'm fascinated by number theory, Terence Tao, Andrew Wiles' work, but I think that you're right, and I'm excited to really and capture like the math anxiety sort of ways to handle that, putting it together in a little write-up, and then really helping kids over the summer to get them more comfortable and see that math is
Yes,
doable, it's beautiful, it's gettable. I know there's other things that are beautiful, but people don't give math enough credit for being beautiful. That's why I have to remind them.
I agree.
Yeah.
100%.
Yes. Wow. Thank you. Thank you. Whoa, that was a lot. That was a lot. A lot to run through there. Thank you for your time. Did you have any final thoughts, comments, questions, objections?
I don't think so at this time, but thank you for the conversation. It was great to talk through and hear your input. I've got a reading list for the summer now from you. So I got 4 books written down here. I'm going to be checking out. So
Yes.
thank you for that. And thank you for having me on.
Yeah. Are you teaching this summer at all?
I'm teaching just online. That allows me to travel with the family and have a little bit of fun while I'm at it. So
Okay. Well,
I'll
if
be
you ever
teaching
run
from
into
around the
it.
world this year.
Oh, okay. Are you doing England or no?
No, unfortunately, not yet. I really want to get to England, but my wife and I want to spend a whole month in England. So we're going to wait till the kids are graduated and moved out so that her and I can just do a 1 month England trip.
Okay. Well, my brother runs. He's one of those in management for the train systems in England. So if you ever need a resource in England, we have a lot of people there. We
Got
can
some
help you
connections for
navigate.
me. All right.
So yeah, no, thank you, thank you. I really appreciate it, and I look forward to hopefully talking to you again at some point. Maybe on Instagram someday. I don't know if you ever do those lives. If you ever wanted to chat on your Instagram that way too.
I do sometimes do some lives on there. I want to get more into it. It just need the time to do it. So if we want to organize something, we can make that happen.
Oh, okay, that sounds good. Oh, last major question: did you go to Liberty or you did online Liberty?
I did both. So my program had 2 summers that I had to go in person for classes, and then the rest was all online. So it's kind
Okay.
of a hybrid.
A hybrid. Okay, no problem. No, they have a great program there. I've heard about their program. I'm actually potentially thinking of doing a PhD someday in math, just so you know. And so I just think it's beautiful, and I would love to learn it as much as possible as a hobby. But first, I need to feed the family, and then I'll get my hobby to become the main.
It's
Imagine
important.
if my job was just going to school for math. I mean, how cool would that be? So
I
yeah,
could get behind that.
yeah. Well,
It
thank you
doesn't
so
pay
much.
very well, but
Oh, it doesn't pay well, you said?
and going to school doesn't pay well. It's a lot of fun, but it doesn't pay well. So
Doesn't, yeah. Yeah. Well, please thank your wife and the kids for giving you time to hang out with me. Thank you so much. I appreciate it.
excellent. You have a wonderful rest of your day.
You too. Take care, Dr. Wallace.
Bye.
Bye.